Hey everybody. Okay, in this video we're going to talk about objects in equilibrium, but then we'll do some 3D examples, right? So if you have, right here, use these tables from the book, reactions at supports, but now let's try some 3D examples. So here, like this L-shaped bar, this is a fixed support here, right? And then we have a cable over here. So if you draw the free body diagram, it's kind of like it's 3D now, right? So we have this tension in the cable, which is, we can get it, right? It's 800 pounds, and then the unit vector from A to B, which we could solve for that, right? But then the fixed support, if you look right here, this is fixed support in 3D. What a nightmare, right? There's a reaction force, which has X, Y, and Z components, and then there's a reaction couple, which also has X, Y, and Z components. So it's kind of just a big mess of 6 unknowns. So there's, right, that's point C, so this is like CX, CY, CZ, right? So that's the reaction force at point C decomposed into XYZ components. And then there's a couple, M, there's the X component, M, there's the Y component, reaction, the couple, M, Z component. So 6 unknowns right there. But we can write 6 equations because we can decompose Newton's second law for forces into 3 components, and then for torques into 3 components. So okay, let's do a little bit of work here. So vector T, that's 800 pounds, and then the unit vector from A to B is 6 minus 4, 2, and then 0 minus 4, and then in the Z direction 4 minus 5. Okay, so we got it, right? This is a known, right? That's known. So then when you write some forces in X, some forces in Y, some forces in Z, right? These are known, these are unknown. So that means you can solve, right? 3 equations, 3 unknowns. Okay, and then now let's sum torque. So if you sum torque about any point we want, so let's say I'll sum the torque about here, about point C. I think is clever because the torque by Cy is 0, by Cx, by Cz, right? The torque by those 3 forces are 0, which is good because those are unknowns. So I would really only need to compute the torque due to this force about point C. So really it's just about point C, right? Is from C to A cross this. Right, so you write this out, it's going to be like something, 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 but this is in equilibrium, which means whatever you have here is 0, right? Whatever you have here is 0. Whatever you have here is 0. So see, this is another 1, 2, 3 more equations. Okay, so give that a try. Let's try this other example. So we have this bar, and then there's a ball and socket joint here, which means it can provide a reaction force that I can decompose into x, y, and z components. So that's at point O, so I'll just call it O. But it's a ball and socket, so it can't provide any couples. It'll just rotate. So that's good news, right? And then there's this rope, and then this other rope, and then there's this load over here, which is known, 600 pounds. Oh, and the bar has weight too. Okay, so the weight of the bar. And then this is known. I'll just call this is known, right? This is known. This is known. Okay, so same exact strategy. You just some forces in x, some forces in y, some forces in z, but just it'll take a bunch of effort, right? Because you want to define this vector as some unknown, but then you can get the unit vector from A to B, right? You can solve for this. And then same story from A to C. This is unknown, but this you can get. And then right, you just write these three. Three equations. And then next you go some torque about anywhere you want. So either some torque about here or here. Both would be good choices. I think this one is a little bit better because there are 3 unknowns. Over here there are just 2 unknowns. So I would sum torque about point O. Sum torque about point O, right, which is from O to point A, and then from O to point A, cross, and then there's all those A, B, A, C, and then that other load, plus R from O to the center of the bar. I'll just call this point D. Just call this point D, since it's the next letter for labels. Cross the weight of the bar. Right, so you do this whole cross product, you're going to get something I, something J, something K. Right, but then this equals 0, this equals 0, and this equals 0. So another 3 equations. So you have as many as 6 equations. Okay, so give this a try. Let me know if you need help. Okay, I'll see you in the next video.